Welcome, developers, to a deep dive into the Model Context Protocol, or MCP. As technical professionals, we often wrestle with the sheer complexity of orchestrating AI workflows, from data ingestion to model deployment and monitoring. MCP tackles this head-on, effectively acting as the advanced IDE for your data and models, streamlining complex AI pipelines so you can focus on crafting innovative solutions, not wrestling with infrastructure. At its core, MCP isn't just another tool. It's a meticulously crafted layered architecture. Think of it as a robust platform designed to abstract away the underlying complexities. We're talking about dedicated layers for data abstraction, sophisticated model orchestration, and a resilient, high-performance runtime environment. This modular approach ensures both flexibility and maintainability as your AI initiatives scale. Driving its functionality is a focus on seamless integration across your data and machine learning pipelines. MCP offers intelligent connectors for diverse data sources, comprehensive tools for transformation and lineage tracking, and robust versioning for both data and models. This means your feature stores, training data, and inference pipelines are managed cohesively, reducing friction and inconsistencies. Now you might be thinking, how does this actually execute? Well, the heart of MCP is its AI runtime environment. This is where your models come to life, leveraging containerization for consistent execution and distributed computing for unparalleled scalability. In real systems, this often shows up when teams face bottlenecks deploying custom inference APIs, or struggle to allocate GPU resources dynamically for training large models. MCP's runtime intelligently manages these computational resources, ensuring optimal performance and cost efficiency. Crucially, MCP prioritizes the developer experience by providing a suite of intuitive APIs and SDKs. Whether you're scripting in Python with its comprehensive SDK, interacting via a powerful CLI, or integrating through its RESTful APIs, MCP is designed to fit your existing workflows. It's about empowering you to build, test, and deploy with confidence, directly from your preferred development environment. For enterprise environments, security and governance are non-negotiables, and MCP is built with this in mind. It provides granular access control, ensures compliance with industry regulations, and offers comprehensive audit trails for every operation. Data lineage and model traceability are baked in, providing the transparency required for regulated industries. Finally, MCP offers powerful extensibility to adapt to your unique tech stack, with a plug-in architecture and support for custom modules. It's not a black box, but a platform you can mold. Being cloud agnostic, it empowers you to deploy and manage AI workloads across hybrid or multi-cloud infrastructures, future-proofing your investments. Next, let's explore precisely why this architectural approach matters so profoundly for developers like you. After understanding MCP's architecture, the real question for any developer is, why does this matter to me? How does it actually change my day-to-day, my codebase, or the projects I deliver? First, let's talk about development velocity. MCP provides standardized, pre-configured environments and modular components, drastically cutting down on boilerplate code and setup time. You're not just coding faster, you're iterating more intelligently, moving from concept to deployment with unprecedented speed. This velocity doesn't come at the cost of code quality. In fact, MCP enforces best practices for data lineage, versioning, and model governance. This leads to cleaner, more maintainable codebases that are easier to debug, audit, and contribute to as a team. Scalability, of course, is paramount in AI. MCP handles dynamic resource allocation and horizontal scaling for your models and data pipelines automatically. Whether you're processing gigabytes or petabytes, MCP ensures your system scales without requiring manual infrastructure gymnastics. In real systems, this shows up when a model trained on a small dataset suddenly needs to process real-time streams from millions of users. Without MCP, that's a frantic scramble to re-architect. With MCP, it's often just a configuration change, maintaining optimal system performance and resource efficiency. Beyond just performance, MCP offers robust integration capabilities. It acts as a universal adapter for diverse data sources, custom models, and existing enterprise systems, eliminating the usual headaches of interoperability and data silos. You're connecting complex pieces with far less friction. Ultimately, MCP is the advanced IDE for your data and models, streamlining complex AI pipelines so you can focus on crafting innovative solutions, not wrestling with infrastructure. You might be thinking, How can I stop dealing with the plumbing and just build? This is how. This frees you up to innovate, to tackle those truly challenging, high-value problems that differentiate your work. It's about future-proofing your AI projects, ensuring they remain adaptable and performant as the landscape evolves. But how do these advantages translate into concrete projects? Let's dive into some specific technical use cases next. Having explored MCP's core advantages for developers, let's now dive into some tangible, technical use cases where it truly shines. Transforming complex problems into streamlined solutions. Remember, MCP is the advanced IDE for your data and models, streamlining complex AI pipelines so you can focus on crafting innovative solutions, not wrestling with infrastructure. Here's how it empowers you in practice. First, consider the perennial challenge of complex data integration pipelines. You might be thinking, my current ETL processes are a spaghetti mess of scripts, often breaking, and schema changes are a nightmare. I've seen teams spend weeks debugging data lineage issues, or struggling with inconsistent data versions across training and production environments. MCP resolves this by providing a unified data orchestration layer, enforcing schemas, and automating data versioning and lineage tracking. The result? A robust, auditable data foundation. Next, let's talk about low-latency model inference at scale. Imagine deploying a real-time recommendation engine that needs to respond in milliseconds under peak load, while dynamically managing expensive GPU resources. The operational overhead here can be staggering. MCP abstracts away the underlying infrastructure, offering an optimized AI runtime for inference endpoints. It handles auto-scaling, intelligent resource allocation, and even supports advanced deployment patterns like canary rollouts, ensuring your models perform optimally without manual intervention. Finally, the critical area of consistent feature engineering. How do you ensure the features your model was trained on are exactly what it sees in production, avoiding train-serve skew? And how do you update those features quickly and reliably? Without a robust system, this often leads to subtle model degradation or frantic, error-prone updates. MCP integrates a powerful feature store, ensuring consistent feature definitions and computation logic across both training and serving environments, dramatically simplifying feature management and accelerating iteration cycles. These are just a few examples of how MCP directly addresses deep technical pain points, enabling developers like you to move beyond infrastructure toil and focus on the innovation that truly drives value. What kind of advanced AI pipelines could you build with this level of streamlined efficiency? Let's explore the tools and ecosystem that make this possible next. Alright, developers. So we've seen MCP in action, tackling complex use cases. But what truly powers this system? It's not just a standalone platform, it's an ecosystem. Think of it this way. MCP is the advanced IDE for your data and models, streamlining complex AI pipelines so you can focus on crafting innovative solutions, not wrestling with infrastructure. To achieve that, it integrates seamlessly with a constellation of robust tools you already know. First, at the foundational layer, we're talking about core orchestration and data management. For robust, scalable AI, you're almost certainly leveraging containerization with Docker and orchestration with Kubernetes. These aren't just buzzwords. They're the bedrock for deploying and managing your AI services. Then, for data ingestion and processing, tools like Apache Kafka for real-time streams and Apache Spark for big data analytics are crucial. These ensure MCP has the high-quality, high-velocity data it needs to operate. Moving up the stack, MCP directly supports your ML development and runtime environment. You're building models with powerful frameworks like TensorFlow or PyTorch, and manipulating data with libraries like Pandas and NumPy. If this feels familiar, you're on the right track. MCP acts as the intelligent runtime, providing the compute and environment isolation these frameworks demand. It's about leveraging your existing expertise without the boilerplate setup, enabling you to iterate on model architectures faster than ever. Now, how do you connect your existing codebase and systems to MCP? This is where dedicated SDKs and APIs become invaluable. MCP offers client SDKs, typically in Python or Java, alongside comprehensive REST APIs, and potentially GraphQL endpoints. These provide programmatic access to MCP's functionalities, from pipeline execution to model versioning. I've seen teams dramatically accelerate their development cycles by using MCP's Python SDK to integrate model training and deployment into their existing Django applications, enabling seamless continuous delivery of AI features directly from their familiar IDE. Beyond core development, an effective MCP implementation thrives on strong CI/CD and MLOps pipeline integrations. This means hooking into tools like Jenkins or GitLab CI/CD for automated testing and deployment. For dedicated MLOps, platforms like MLflow for experiment tracking and model registry, or Apache Airflow and Kubeflow for workflow orchestration become natural companions. MCP is designed to be a central component within these automated pipelines, not a silo. Finally, for any enterprise-grade AI solution, data governance and security are non-negotiable pillars. MCP integrates with solutions like Apache Ranger for fine-grained access control on data, and HashiCorp Vault for secure secret management. Identity providers such as Okta or Azure AD ensure authentication and authorization are handled centrally. These integrations mean your AI automation isn't just efficient, it's also compliant, secure, and trustworthy. Understanding these supporting components is key to building truly robust, future-proof AI. Next, let's explore the best practices for developing and deploying with MCP. Welcome back, developers. We've explored the MCP ecosystem. Now let's get practical. How do we effectively leverage this powerful platform? We're diving into best practices for MCP development and deployment. This isn't just about coding. It's about architecting a seamless, scalable, sustainable AI lifecycle. First, embrace iterative development workflows. MCP empowers agile AI. Think microservices for components, segmenting training, inference, and data pre-processing into containerized units. This inherent design enables rapid prototyping and independent iteration, breaking monolithic projects into modular, testable pieces. MCP is the advanced IDE for your data and models, streamlining complex AI pipelines so you focus on innovative solutions, not infrastructure. This modularity speeds cycles. Next, comprehensive automated testing is non-negotiable. AI demands more than traditional unit tests. You need robust strategies. Unit tests for model components, critical integration tests for data pipelines. Also, dedicated performance testing for inference latency, and data validation tests to ensure input quality. You might be thinking, how do I ensure my model behaves as expected across diverse, evolving datasets? MCP's environment facilitates these complex test suites, ensuring reliability before deployment. Moving to production, seamless CI/CD deployment pipelines are paramount. MCP simplifies orchestrating automated build, train, and test cycles. Deploy models confidently using advanced strategies like canary or blue/green deployments for zero downtime transitions. These MCP-supported practices include rollback mechanisms, giving you a safety net for production-grade AI. In real systems, this shows up when a critical model update needs to go live without any downtime or performance degradation. MCP automates orchestration from artifact management to infrastructure. Then, there's robust version control and collaboration. For AI, this goes beyond just Git for code. You need systems like DVC or MLflow to manage model versions, track experiments, and log every parameter and dataset iteration. Without clear versioning for models, data, and code, debugging subtle performance regressions becomes a nightmare. MCP's integrated environment encourages these practices, allowing collaborative branching for developers, ensuring traceability and reproducibility across your ACI project. Finally, post-deployment, proactive monitoring and observability are key. It's not deploy and forget. You need real-time dashboards for model performance, tracking metrics like accuracy. Implement data drift detection to alert when input data deviates from training data, potentially degrading performance. Anomaly detection for inference outputs and continuous resource utilization monitoring are crucial for health and cost efficiency. Closing the loop with robust observability ensures your MCP-driven solutions remain high-performing and adaptable. These best practices, implemented with MCP, transform your AI development from hurdles into a streamlined, innovative journey. But what truly sets MCP apart from the rest? That's what we'll uncover next. We've covered MCP's capabilities, but what truly makes it unique? It's in its core architecture and the direct technical advantages offered. First, high-performance AI runtime optimization. MCP's runtime is purpose-built, deeply optimized for AI workloads. This means intelligent memory management, accelerated computation, and smart resource scheduling. Developers gain less infrastructure tuning, more focus on algorithms. Secondly, MCP boasts a truly scalable microservices architecture. Every component, from data ingestion to model serving, is containerized and designed for horizontal scalability. MCP dynamically adjusts resources, preventing bottlenecks during peak loads and optimizing costs during quieter times. You're deploying an elastic, resilient system handling fluctuating traffic or massive data spikes effortlessly. A critical differentiator, often overlooked until crisis, is unified data and model versioning. Imagine Git for your entire AI pipeline datasets, pre-processing, models, evaluation metrics. MCP provides auditable version control for all artifacts, ensuring full reproducibility. I've seen teams lose weeks reproducing phantom bugs or specific model output because they lack this unified versioning. With MCP, you can roll back and compare with confidence. Beyond versioning, integrated observability and diagnostics forms a bedrock of reliability. If you've ever struggled to pinpoint a failure in a complex AI pipeline, you understand. MCP integrates comprehensive monitoring, logging, and tracing directly into your workflows. It provides real-time insights into model performance, data drifts, and system health. This moves you from reactive firefighting to proactive problem-solving, improving uptime and team efficiency. Finally, MCP offers unparalleled multi-cloud and hybrid deployment flexibility. Vendor lock-in and regulatory concerns are significant. MCP is fundamentally cloud-agnostic, supporting seamless deployment across major public clouds, private clouds, and on-premise. This means you deploy AI solutions precisely where they best serve your business, leveraging existing investments and avoiding migration headaches. Much like an advanced IDE for your data and models, MCP streamlines these complex AI pipelines, freeing you to innovate. Understanding these differentiators is crucial. Next, we'll dive into debugging and troubleshooting MCP to navigate common pitfalls and find robust solutions. Even with an advanced IDE like MCP for your data and models, you'll inevitably hit unseen issues. My code works locally, but production, silent pipeline failures, intermittent model drift, or sudden dependency breaks aren't just annoyances, they're innovation blockers, forcing you to wrestle with infrastructure, not craft solutions. Understanding these failure modes is crucial for true resilience. One prevalent pitfall is configuration mismatch, leading to environment drift. Your local setup works, but CI/CD fails due to inconsistent variables, out-of-sync dependencies, or subtle YAML errors. These small discrepancies cascade, breaking AI pipelines. Pinpointing them demands a systematic approach to environmental consistency. Data ingestion and transformation often bottleneck pipelines. A state-of-the-art model is useless if data is slow, malformed, or too large. I've seen teams debug models for days, only to find the root cause was an inefficient join or schema mismatch upstream. These manifest as out-of-memory errors or increased latency. MCP helps visualize data flows, but you need to know where to look. Performance degradation under load is another notorious failure. This stems from resource contention, unexpected CPU/GPU saturation, memory leaks, or network latency. Your AI system seems stable until a request surge slows or crashes everything. Diagnosis requires deep system metrics, beyond error logs, to identify bottlenecks like I/O wait states or inefficient algorithms consuming resources. Fortunately, MCP offers a powerful debugging arsenal, extending your IDE's capabilities to the entire AI pipeline. Leverage centralized, structured logging for quick filtering. Distributed tracing is critical for understanding flow and latency. Real-time metric monitoring for CPU, RAM, and GPU is non-negotiable. Proactive custom health checks and alerts flag issues before they impact users. Practically, isolate the problem domain, code, data, or infrastructure. Then, reproduce the issue consistently. Don't underestimate MCP's rollback and versioning for quick recovery. Proactive measures. Rigorous automated integration tests are paramount. Regular infrastructure audits prevent environment drift. These transform debugging into a systematic, efficient, and predictable workflow. Next, we'll explore hands-on steps with MCP. After diving deep into debugging and troubleshooting, the natural question becomes, okay, I understand the why and the how for common pitfalls, but how do I actually start building with MCP? The journey to mastering AI automation begins with focused exploration, and we've curated the perfect pathways for you. First, immerse yourself in the official documentation. Think of it as your comprehensive technical spec sheet. Here, you'll find everything from detailed API references and SDK guides to quick start examples that get your first project up and running in minutes. Remember, MCP is the advanced IDE for your data and models, streamlining complex AI pipelines, so these docs are your blueprint to navigating that powerful environment. Next, graduate from reading to doing with our hands-on tutorials and guided labs. You might be thinking, documentation is great, but I learn best by coding. Exactly. These resources walk you through end-to-end projects, from integrating data sources to deploying your first automated model workflow. They provide practical, actionable steps to build foundational understanding. Then, don't underestimate the power of connection. Join the MCP developer community. I've seen teams accelerate their problem-solving tenfold just by engaging with peers facing similar architectural challenges. Our forums, Discord channels, and GitHub discussions are vibrant hubs where you can ask questions, share insights, and even contribute to the evolving MCP ecosystem. This collaborative environment is invaluable for real-world learning and overcoming obstacles. Finally, for those ready to push the boundaries, we've crafted a conceptual coding challenge. Imagine automating a complex multimodal data ingestion pipeline, or building a custom model orchestration workflow that integrates a new, exotic third-party API. This isn't just about syntax. It's about leveraging MCP's capabilities to craft truly innovative solutions, not wrestling with infrastructure. So take that mental leap. Thank you for joining us on this deep dive into Master AI Automation. If this journey resonated with you, please hit the like button. Share your biggest takeaway or your thoughts on the conceptual challenge in the comments below. I read every single one. Don't forget to subscribe and hit the bell icon to stay updated with our latest developer insights. And for the full, in-depth playbook with all resources, check the link in the description.